In this video, we're going to look at loci. Loci is the plural of locus. A locus is a set of points that obey a rule. As you go on with your maths, you'll see that this can apply to an equation and its graph. So if we were asked to sketch the graph of y is equal to x squared, the parabola would be the locus of points that satisfy that equation. In this particular video though, we're going to look at some practical applications and look at drawing the locus for a range of different scenarios. So let's start off and look at a typical question. We're asked to draw 1, the locus of a point which moves so that it is always exactly 4 centimetres from the fixed point x, and 2, the locus of points less than 4 centimetres away from the fixed point x. If we have a locus of a point now that's exactly 4 centimetres from this fixed point, we will get a circle. So let's have a look at that now and we can trace this out. So what I'm going to do is take now the compass and I'm going to open this up now to 4 centimetres. So placing this on the ruler, we can just open this up now to 4 centimetres and that will be somewhere around there. We now put it on this point. So what I'm going to do is draw the locus now of a point. So this point is simply going to move around like so. So a locus of a point will be now a line, and in this case, if it's a fixed distance from a fixed point, it will always be a circle. So that's part A done. If we want to answer part B, we're now interested in the points, the locus of points less than 4 centimetres away. That now is all of the region inside the circle. So we'll go ahead and shade out everything in this circle right the way through. These are all of the points now that are going to be less than 4 centimetres away. So let's just move this out of the way and we can shade that. Now this particular example does have some real world applications. So for example, when you order a pizza, you might now see in the pizza place a map like this. This now gives us the locus of all of the points that this company will deliver to for free. So we can see now that we've got what should be a circle right here, and this is the free delivery zone. You're going to pay now if you go outside, or there will be some additional condition for you. So that's a nice practical application. So to recap, the locus of a point will be a line, and then the locus of points will either, you can see this either as a region or an area. Okay, let's look at another example. We're asked to draw the locus of points no further than 3 centimetres from A and no further than 4 centimetres from B. Okay, so let's grab up the compass again. So right on the ruler, and we'll start with A. So we'll open that now to 3, and that will be about there. Okay, so what I've got now, let's just draw that point on. This now is going to be the locus. So the locus of points is everything now in this circle. That satisfies the first condition. What we now need to consider is 4 centimetres from B. So I'm going to open this up now like so. So 4 centimetres from B, and we'll place this on and then just show that. Now what we want is now the region that satisfies both of these. So that's going to be the shaded bit now in the middle. So what I want then is this part right here. So this part is no further than 3 centimetres from A and no further than 4 centimetres from B. If you want to think of a practical application of this one, if you consider 2 children now living at house A and house B, their parents might say to them, we don't want you in house A to be any more than 300 metres from house, and the parents of this child might say we don't want you any more than 400 metres from the house, but they want to hang out together. This is the area that they could hang out. So this now is looking at the locus of points that satisfy 2. So draw the locus of points no further than 3 centimetres from A, and that's a key word, and no further than 4 centimetres from B. Okay, we're asked to draw the locus of a point exactly 3 centimetres away from a straight line AB. Now let's consider this one. What we want then is some now 3 centimetre line here. And we can do this now by simply setting the compass first to 3 centimetres. If we consider what we've just looked at, and we'll just open this up, we're going to have now this distance. Now this distance from A If I take a 3 centimetre distance, that creates a circle. If I do exactly the same now from B, so if I pick the compass up, we will have this. So what I've now drawn are now the loci just here. These are the points that are going to be 3 centimetres away from both. But now consider we need to be 3 centimetres away from this line. All we need to do in this particular scenario is now draw a straight line across the top here. So what we've got now is this part, and let's just move this out of the way, move the ruler, and then we end up now with this part right here. Now when you're doing this, you need to ensure that you're leaving your marks on here, your construction marks. So let's just tidy that up a little. And what we end up with now is the following scenario. We've got this, and let's just make that look a little tidier. We've got this picture right here. So this now is the locus of points that are going to be now at exactly 3 centimetres away from the line. I would be tempted at this stage now just to highlight this, and I'll do a very poor job of just going round here. It's going to be this right here. So we're coming round this part right here. Obviously you'll do this quite neatly, but of course it doesn't apply to this part right here. It's applying to what I would call the running track round the outside, just so I can highlight that to you. It's this part right here. This now is the locus of points exactly 3 centimetres now from the line AB. I like to think of this as either a running track or now a treadmill, and you must now leave on your construction marks. Don't try and fudge it, simply draw those out. So draw the locus of point, locus of a point, so it's a locus of a point rather than points. If we were asked for the points, then we would simply now shade the inside. If it was less, we would shade the outside if it was more. So that's an example now of drawing a locus of points given a straight line. Okay, let's move on to another one. In this one it says in part 1, draw the locus of a point equidistant from the points x and y. Now when we think equidistant, we think perpendicular bisector. If I now create a perpendicular bisector of these 2 points, we will find a straight line that cuts now this in half. So let's go ahead and do that. What I'm going to do is open this up, and generally with this all we need to do is go a bit further than halfway. So let's just spin that round. That will be perfectly fine. In fact, I could probably close it up a little more. So what I'm going to do is simply now draw up, and I'm going to swing an arc. I'm going to swing an arc back down this way. Now without altering the compass, I'm going to move it to this point right here. Don't change the compass at this point, and let me just spin that back round. What we'll now have is this right here. So let's draw that, and now we can draw the locus of points that are equidistant from these 2. So all I'm looking to do here, let's just move this stuff out of the way. Again, you will have to just connect this up to show quite clearly what you're doing. And now what I'm going to have is that, and I'll continue that. Let's just go there. That now is the perpendicular bisector, and this now is the locus of points. Let's just see if we can change the colour of that. It's a bit bright. Let's go for that one. So there we go, that's what we've got. So this now is the locus of a point equidistant from the points x and y. We now need to draw the locus of points closer to point x than to the point y. So all we're doing is shading now to the left of this line. So let's grab up a colour and we'll shade. So we want the points closer to the point x, which is going to be this side of the line. And I won't go over the text, but hopefully you can see now what this is going to look like. So up to, now let's just get rid of that bit, don't need all of that. Let's get rid of that. So it's up to now that line. So all we're doing is simply shading now the points that are going to be that closer to x than they are y. Okay, so that's this part right here. Now what we need to do here is draw the locus of points closer to x than y, but no less than 5 centimetres from x. Okay, so let's consider what we're going to have here. Let's redraw this one. So what I'm going to do, and we'll just see if we can spin this back into place. Let's grab that up. So what I'm going to do now are the points that are going to be 5 centimetres. So let's see if we can move that into place. And now we'll change. So all I'm doing is measuring out 5 centimetres. Let's get that looking a bit straight. As, well, I've not yet stated, but I would suggest when you do this that you'll probably find it easier now to do. Let's grab up a different colour. You'll probably find it easier to do if you're actually doing this with a proper compass. Okay, so this now is going to be the 5 centimetre line. So let's now draw that. So what we want then is the following. We want, in this particular case, and now we can ignore the green part, we want, and let's move that off, no less than 5 centimetres from X. So what I'm going to have, and I'll do this part in purple, that's going to be all of this part. So the points closer to X than they are to Y. So it's right up to this line now here. So we're closer to X than we are to Y, but we're not now going to be within 5 centimetres, and that's the purple bit right here. So I need to be closer to X than I do Y, which is this line, but also no less than 5 centimetres from X. And that gives us all the purple part, and quite clearly it'll be all up here as well, and it will be round this way. So that's a nice one where we've got 2 conditions to satisfy. So on this one, perpendicular bisector, and if you've not seen that, I've done a video on this, and then think about the shading. Okay, we need to draw the locus of points closer to the line AB than the line BC in the rectangle now ABCD. So if we consider what we've got here, we've got this right angle. Now what we're going to do here is an angle bisector in this case. So we did a perpendicular bisector last time, we're going to do an angle bisector. So what I'm going to do is place this like so. I'm going to open this up and just spin it round. So what I'm going to do at this stage now, let's just open it up just a touch further. Let's grab that and we will open that up like so. So what I'm going to do is place this here, and I'm going to now draw arcs, or if you like, just now mark an arc. I'm going to mark an arc here, and then I'm going to mark an arc down here. Without changing now the compass, I'm going to move it on to these points right here, and then I'm going to swing now another arc. So getting it bang on just here, I'm going to put another one up here. I'm going to take this off, I'm going to put it down here, and I'm going to swing the arc. So swinging the arc gives me this. Once I've done that, the point of intersection now here is going to be the point where those 2 arcs meet. So let's go ahead and draw now that, and we can put that on, and that's going to look something like so. Now I'll assume that this is going to be points inside the rectangle. So let's just change that colour, and we'll have that one. So there we go. So we want now the locus of points closer to the line AB than the line BC in the rectangle. So all we need to do is shade to the left of this line. So let's go ahead and do that. So what we're going to have then is this. This now is going to be the points right here. So all of these points are closer to AB than BC. So all of that now to this side. And again, when you do your shading, just nice ruler shading up to the line, and that's job done. So they're the points closer now to AB than they are to BC. I've just simply done now an angle bisector and considered those. So if you're given points closer, think region or area, or if you're given a point, consider it to be a line. Okay, let's have a look at a practical application, as realistic or as it may seem. A dog is on a lead tethered to a post in the corner of a garden. So here's the post. The lead is 5 metres long. A cat is free to roam all parts of the garden, but is not allowed within 3 metres of a house by its owner. Show the safe area that the cat can safely roam on the diagram below. Okay, the wording isn't brilliant, but hopefully we understand what it's asking us to do. So what we need to consider now is the dog. So if we look at the dog, what we've got then is the dog, and we'll do this. The dog now can have a lead of 5 metres. Now if we just look at this scale, let's just get the scale right. If that's 10 metres now, then 1 centimetre is going to be now a metre. So let's put this on and do that. So do check that scale. I just had a quick look and it looked right. I'm just concerned that that is correct, and it is. That'll work. So let's now get a 5 metre locus. So what we'll do is open this up. Right, let's grab that. That's what we want. and that will be 5 centimetres. So the dog now, and I'm going to just come around this way, the dog, in terms of the garden, I'll be outside the garden at this point, the dog can do anything now in this region. So that is going to be now its essentially its range, isn't it? So if we consider, and we'll do this red for danger, let's do that area, that's going to be now the danger area. So what we're going to have then is this right here, and this is certainly an area where the cat will not be safe. I'm assuming that the dog can kick the cat's ass, but well, we'll just assume that. We'll just assume that the dog is the sort of the beast of the two. Okay, now the cat is not allowed to now roam within 3 meters of the house. So let's now just swap this around, and we'll do a 3 meter locus. So let's now open and close this up to suit, and I'll just swap the colour. So let's think of a different colour. Let's have green. So what we'll do then is just move this into place. So the cat now can't go, and I've just opened this up now to 3 meters, give or take. It can't go within 3 meters of the house. Let's say that there's a kid playing and the family have fenced this off. So what we're going to have here is something that does that. Okay. So again, this is going to be a no-go area for the cat. So what we'll do, we'll just block this out, and let's get rid of that. So it can't go in this part right here. And what we'll have now, let's just shade up like so. This then is going to be, and we can write this on, let's grab up a different pen. This is going to be the safe area. So let's just jot that on, S-A-F-E. That is the safe area where the cat can roam. So it's not allowed within 3 meters of the house, that's 3 meters of the house. It can't now go within 5 meters. Remember, this dog is on a lead, and it's probably some salivating hound that wants to eat the cat. I'm not going to draw a cat. I don't want to ruin my video with, oh, I'll do it anyway. I didn't want to ruin it, but I will. Here's the cat, okay? There we go. Absolutely brilliant. So the cat can go anywhere in here. It doesn't want to go within 5 meters of the dog, as this is on a lead. So there we go. That's a nice practical application of now drawing the locus of points. So there we go. You're going to need to know basic constructions, but again, if you've seen the video on that, this should make sense. So there we go. Loci, or the locus of points.